So good morning. Thank you for attending this session on the IIS Rearchitecture and Reliability. My name is Jeff Kercher, and I'm a program manager on the IIS 6 team. So the first part of this talk, we're going to go into the IIS 6 architecture, and we'll be going into some technical details of how IIS 6 works. We'll also talk about improvements of IIS 6 over IIS 5 in terms of the process model. Well, I can't discuss all of the features, all the new features in IIS 6. I'll discuss some of the key features that focus around reliability, and these are application pools, recycling, and health detection. Then we'll talk about some application design considerations for IIS 6, and then probably should have about 10 or 15 minutes of Q&A at the end. IIS 6 was fundamentally redesigned from the ground up, and I want to talk a little bit about what were some of the primary drivers for this re-architecture. So some of our current challenges centered around availability. So we wanted IIS 6 to be up and running all the time. And so in a scenario where you were hosting hundreds or thousands of applications, when one of those apps crashed or went down, we didn't want that to take the system down with it in all cases. Application isolation is also a big deal. So we wanted to be able to scale up to having multiple fully isolated apps running in their own process, running on one machine. In IIS 5, you may have encountered some limitations with the amount or number of totally isolated web apps that could run on one server. So we wanted to increase that. I mentioned IIS Reset here because that was a command line tool that came with Windows 2000, and it was used to reset the entire web server. And we found that site administrators were using this almost as a management tool, scheduling it to shut down IIS because they were hosting applications that were going down and disrupting service on the web server. So we wanted to make IIS 6 smart enough to understand when connections needed to be reset. So we built some of this feature into the product itself, so you didn't have to schedule a command line tool to do that. So before we can get into the internal architecture of IIS 6, we'll spend a little time reviewing how IIS 5 works to establish a frame of reference. So at the lowest layer, you have WinSock and TCP/IP, and that's where the requests come in from the network. Part of the W3 SVC service was inetinfo.exe. Now this is a host process that stores the IIS metabase, which is the configuration information, and as well as serves as a host process for running in-process ISAPI extensions and all ISAPI filters. Out-of-process, web applications that are running out-of-process or in pooled mode ran in instances of DLLhost.exe. And that DLL host is actually a part of the COM Plus subsystem. So we leveraged that in the IIS 5 architecture. Now, what happened in IIS 5 when applications had failures or AV'd inside inetinfo, inetinfo would be taken down, but we have code inside of the SCUM, the Service Control Manager, to automatically restart instances of inetinfo when that happens. And that works pretty good in some cases, but there will be a lapse of service when the IIS is being restarted, and it also couldn't detect when there was thread deadlock inside any of the ISAPI filters, possibly extensions like ASP running in process with inetinfo. So there was times when IIS would be locked up and it wouldn't automatically restart itself. So one of the goals of the new architecture is to enable complete isolation from applications and the web server components itself from affecting anything else. And to do this, we split IIS 6 into three major subcomponents. We have a kernel mode component, and that's called http.sys. We have the web admin service, or WAS, which is a user mode process. And you have the web processing cores. And as we'll talk about later, as we go into each of these components, there can be multiple instances of these web processing cores running. So we'll kind of start and go into each one of these components and describe how they work. So http.sys, and this is the kernel component for IIS 6. This is actually part of the Windows.NET Server networking subsystem. So it's an operating system component that we leverage as part of IIS 6. It's always loaded and running all the time. Like I said, it's part of the operating system. And this is where our HTTP stack is implemented. And internally, it uses kernel mode code to talk to the network. It's through the transport device interface. One of the new features of this component is completely new, but they built in support for listening on IPv6 networks in http.sys. And this talk isn't going to go into too much about transports and protocols, but one of the new features of .NET Server and IIS 6 is support for IPv6. So IIS 6 will be able to listen on IPv6 network endpoints, and it's through http.sys that it does this. So what does http.sys do? It's primarily a request router. So as requests arrive, they are routed based on their URL to the correct user mode process. And it implements a queuing mechanism. So as requests come in, they're placed on the queue and then picked up by the user mode processes that are using http.sys. For performance, it implements its own cache in kernel mode. So there's a chance if the response is in the cache, there's no transition from kernel mode to user mode to return that response. It's directly from kernel mode. In logging, so IIS 5 had text-based logging. In IIS 6, the logging functionality is moved into the device driver. So http.sys is writing out the logs. And there's also a binary logging mechanism in IIS 6, and that's also implemented in the driver. So we'll go into a little bit more on the driver and to give you an idea of how its internal processing works. So the driver provides an API layer, the HTTP sys API, and this is how applications such as that run in user mode, such as IIS, communicate to http.sys. It's through this API layer. So when requests arrive, the first thing that happens is that these requests go into the HTTP parser and engine, and that first checks the internal cache, the response cache. If that request is in the cache, then that response is sent directly back to the client. Now, requests that arrive that are not in the cache, they'll move up into the namespace mapper component. Now, what this will do is, based on the URL, and it implements some logic to direct that request to the proper request queue. And it's through these request queues that any processes in user mode that are set up a channel with http.sys. This is how they pick up the requests and process them. So now we'll move into the user mode components. So the web admin service, and we also refer to that as just WAS by its acronym. And this is part of the W3 SVC service. So it's implemented in servicehost.exe, and it's physically part of the W3 SVC service. This component has two primary roles. One, it's a configuration management app. So all configuration that needs to be passed down to kernel mode, such as setting up the URL namespaces and any properties that you configure, let's say with queuing and caching and things like that, get passed down through the API layer from WAS. It's also responsible for controlling the web processing cores, which are the user mode processes that are running the applications. So if a request comes in, WAS will be responsible for starting that worker process and setting it up to talk to the request queue in http.sys. And it will maintain some information about these running processes. So I talked about earlier that we have these new features like recycling and health detection. It's through this communication or this knowledge that WAS has to the worker process that it can perform these features. So like its kernel mode, like the kernel mode driver, it's important to understand that no application code gets loaded into WAS. So unlike IIS 5, where you had applications running inside INET info that could take down the web server, no application code ever runs inside of the WAS component. And I don't know if I mentioned this earlier, but in kernel mode also does not run any application code. So there's no chance that you can cause something like a blue screen or a serious system failure by running a web application, because it only runs IIS code in both the kernel mode component and the WAS component. Let's see. And that's how it ensures the reliability of the web server. Uh-oh. Okay, the third piece, the third major subcomponent, is the web processing cores. And these are similar, well, they're not quite as similar, but they're implemented as w3wp.exe. I want to say they're similarly to DLL host, but you can imagine if you're looking at your web server and you open up Task Manager, you're not going to see DLL host instances running your web app anymore. You will see multiple instances of w3wp. So these are the main web processing core responsible for handling web requests, and they're basically just Win32 processes. And you want to think of them as a self-contained web server. So when you've set up a website and it's processing a request in w3wp, it's completely isolated from the other components such as WAS. So it's maintaining a connection directly through the HTTP API to receive the request, and then it'll generate the response and send it back directly to the driver. So all web request processing functionality is loaded and executed in this component. So it'll typically either do one of three things. It's either A, if your request is for a static page, it's going to map that request to a file and return it. If it's an ISAPI extension, such as ASP or ASP.NET, it will load that extension and that'll process the web request. Or it could potentially run a CGI executable if you have that configured. So applications, when I refer to ISAPIs being loaded into the worker process, these are typically applications like ASP and ASP.NET, or any custom ISAPI extensions that you might write. And again, filters. So something like the Commerce Server ISAPI filter would run in the w3wp.exe. And because it's its own separate executable and it's isolated from everything else, and that's how you get, reliability and availability. So if you set up separate websites in their own process, I mean, it's through process boundaries prevent it from affecting any other applications. Sure. What?
Yes. The question is, in the current situation, is this a shipping product?
Well, the question is this a shipping product? So IIS 6 ships with .NET Server. So our release schedule, it's with the operating system. So Beta 3 would have this implementation in it. And, actually, if it's possible, I've got quite a bit of slides. We can hold questions to the end. It'll work, but that's fine. So now we'll kind of tie these components together. So first, I'll just review how a request was processed in IIS 5. So the requests arrived at the WinSock layer, went into INET info, which had set up the endpoint through WinSock, optionally processed through any ISAPI filters, and if you had an in-process web application, it would run inside the INET info process. If it was an out-of-process app, or if it was pooled out of process, it was through COM marshalling that the web request would get sent over to the DLL host process, and then that would execute. It would be marshaled back to INET info, and then sent back through WinSock. In IIS 6, it functions different. So requests still come in over the network, but the listening capability is not built in, doesn't use WinSock anymore. It's done through this HTTP sys layer. So that's where the requests are pulled off the network, put on a request queue, and then sent up directly to the worker process that's running that application. And WAS sits off to the side, and like I said, it's sending configuration info down to http.sys and maintaining information about the running worker processes. Now, you may notice in IIS 6 that inet info has not gone away completely. So if you pop open the task manager, you'll still see it. And the reason for that is, although it's not hosting any ISAPs or listing on the network, it still stores the in-memory metabase. So IIS configuration that's stored in memory is still located in this inet info process. And the other components of IIS, such as FTP and SMTP and NNTP, still run inside inet info. And they do not use HTTP, it's hard to say, http.sys. They will go through WinSock. Now, what you may notice here is that in this slide, the worker processes are grouped into these entities called app pools. Now, this is what's called an application pool, and it's a logical grouping of worker processes. So if I want to apply specific configuration to a worker process, I do this through the use of application pools. And so I'll get more detail about application pools in the next slides, but this is one of the fundamental new changes in IIS 6 is the concept of the introduction of application pooling. So application pools is fundamentally how you set up isolation in IIS 6. And so they are a way to group web applications into their own entities that are served by worker processes. So in this screenshot, there's an application pool that's created for each one of the sites that's running on this machine. Now, so the fundamental takeaway, I think, for application pools is that if you have one application pool and you place all your sites in that application pool, they are all going to run in the process that's serving that application pool. So they're essentially going to be running pooled into one process. If I create unique application pools for each one of the websites, then each one of those sites would be running in their own separate instance of W3WP. So and we'll get into later that you can actually configure multiple worker processes to serve a given app pool. And internally, http.sys kind of uses this app pool configuration information to know how to route the request to the proper processes. So this is fundamentally how you configure isolation. And different scenarios you may want to isolate on different kinds of criteria. So if I'm a hosting company, and let's say I'm hosting hundreds or thousands of sites on a box, I could potentially create an individual application pool for each one of those sites. So I could apply specific configuration to each one of those customers. I may isolate, let's say, debug applications into one application pool because they're running in a separate process than, let's say, some production applications, and I don't want them to affect each other. So it's pretty application specific on how you would create application pools, but it's important to remember on how isolation works in terms of using these application pools. So I'm going to switch over to the demo machine. I'm going to do a quick demo of how application pools work. So on this machine, I've got a virtual directory set up, and it's basically a simple ISAPI extension. So I'm going to hit a .dll extension. And what this does is just print out the process ID and the application pool that's serving that, the process ID of the worker process that's serving that application pool. So if I refresh this page, I can see that the process ID is 1588. And I actually have this machine is configured a little special to run the NTSD, the system debugger, on any instances of W3WP that are running. So you will, if you see these command windows pop up, that's what that is. Application pools are stored in their own section in the metabase. So you'll see a new application pools node in the tree in your MMC. So I can create a new application pool just using the MMC or through script, But I'm going to, for this demo, use one of the text edit features of the Metabase to do that. So I have a link to my Metabase on the desktop, and I'm going to open it up and edit it with a new application pool. So there's a lot of stuff in this file, so I found it easier to just do a find and look for the key I'm looking for. So I'm just going to insert a new application pool tag in here and just leave all the default configuration. And I'll call this Airlift pool. Okay. Now when I save this configuration, it should get automatically propagated into the Metabase. So when I refresh, I'll see my application pool available for me to assign web applications to it. Now the way to assign an app to an app pool, you can also do it through direct editing the Metabase or script, but I'll just use the MMC, and I'll choose the properties of my app, which is this virtual directory called dump vars. And under application pool, I'm going to select the Airlift pool. Now, when I go back and refresh the page, you'll see that the process ID has changed, and there's actually a new instance of W3WP up and running, and the old process is still there. There's timeout limits for how long these processes will live. So you can see that it's switched and is now running in an isolated process. So there's properties that you can assign to application pools. Now one of these is the configurable worker process ID. Now what this is the base identity of the process, of the worker process has when it's running. So as we mentioned earlier, WAS is responsible for starting the worker process. So when it starts the worker process and uses create process as user, and it specifies this particular identity for the process to establish as its base security token. So this is different than impersonation. So impersonation is another configurable identity that you can apply to your website. But process identity is completely different than the authenticated user. And I'll give you an example. So if I have an ISAPI extension like ASP, which implements its own thread pool. Now, while it's running and there's no request, that process is running as its base identity, and so are the threads inside of it. Now, when a request arrives and a thread gets selected to run the ASP code, it's going to impersonate the authenticated user that came in through whatever authentication mechanism they were using. So for the brief period of time that it executes the request, it's going to run as the authenticated user. When it's through processing the request, it does a revert to self and reverts back to the base process identity and goes and sits in the thread pool waiting for another request to come in. Now, why this is important is that you want to consider any malicious attacks that could possibly happen to the system. So you don't want any code to take over and do a revert to self and run as some high privileged base identity. So it's important to consider the privileges that you give to the base identity of this process. Now, by default, it's going to be the network service account, which is a very low privileged service account that comes with .NET Server. You can also assign it a predefined account such as local system, which is high privileged, or local service, or you can configure your own any ID and place it in there. So again, I'll go back to the hosting scenario where you've got multiple sites on a box. You may want to assign specific process IDs to even increase the security, where you actually can prevent through process level security any application that goes to one site from possibly, let's say, escaping out of its the folder, the web folder that you have for that site. Now, if you create your own identity and want to use it as your process ID, you'll have to make sure that it's inside this IIS _WPG group. So this is a user group that's part of the operating system that already contains all the required properties that a worker process needs to have for its identity. And the 306 section, I just mentioned this, will have a lot more information. It's the security talk, so it's probably going to go into some more details of how this relates to the larger security picture. So there's a term in IIS 6 that we call a web garden. Now, what a web garden is, it's when you have an application pool and you configure that application pool to have multiple worker processes serving it. So, and this is primarily a reliability feature. So if I set up an application pool and it has 4 worker processes running, if any one of those processes becomes loaded, there's other ones available in the pool to run. It's a similar name, but it's not really related to a web farm, which is a cluster of IIS servers. So a web garden is it's just on the machine, and it's basically when an app pool has multiple worker processes. I mentioned connection-based routing, so HTTP.sys is smart enough to, through the request queues and the app pool mapping, to send requests to all those worker processes in the web garden. There's also a property called processor affinity. So it's possible to bind specific app pools to specific CPUs on the box. So if I imagine I have a quad processor or an 8-way server, I could configure an app pool and bind it to specific CPUs or multiple CPUs on a machine. Now, it's important to remember that all the worker processes within an app pool will go to those CPUs. So if I configure a web garden with 4 worker processes, but bind the application pool to CPUs 1 and 2, those 4 worker processes will just be constrained to running on CPUs 1 and 2. And this is done through an affinity mask, and this is a property of the application pool that you configure. So, I mean, the purpose of this feature is to, for advanced configurations where you're dealing with multiple CPU boxes, you may want to go as far as to, let's say, binding specific network cards to specific CPUs, and then have those CPUs bound to specific app pools. So you can get pretty granular in how you configure, the network, and as well as that goes to the CPUs, then goes to your IIS configuration. So I think we've talked about some of the fundamental subcomponents and app pools, which is a really important concept in IIS 6. The reliability features of IIS 6 are all based off of the use of these app pools. And as I said earlier, it's through the connection that WAS has to these worker processes that allow these reliability features like recycling and health detection to work. So we're going to kind of move into more of these reliability features right now. So there's a feature in IIS 6 called recycling. It's process recycling. And this is an application pool property. And what it is, it's the ability for IIS to periodically restart web applications based on certain configurable criteria. So I can restart a web app based on uptime, based on the number of requests that arrive, based on scheduled times, memory consumption, or I can recycle on demand. So, as an alternative to using IIS reset, I could recycle an individual application without shutting down the web server. So why use recycling? So there's a lot of cases where you're hosting a web server and you're running some code and the developers are no longer there, and you know it's problematic. Let's say it has a memory leak, or it does something with database connections that you just can't change, but you know that it'll run for a while and basically has to be restarted, or sometimes it consumes too much memory on the system. But you can use IIS and configure it to to have some smarts about the application, so it can detect when it's doing these negative things on the system and then just restart that application. And it's also good for preventing these bad applications from taking over the systems, such as if they were using up too much memory. So there's two types of a recycle event that happen. There's an overlap recycle. So what this does is it will terminate the old, only terminate the old process after a new process starts. So it will create a new worker process in place of the other one, then shut it down, and they'll be, for a brief period of time, they'll be running simultaneously. Now the benefit of this, of the overlap recycle, is that you don't drop any requests. So the existing worker process has time to finish sending its responses, and the new ones start going to the new worker process. I'll mention here that there's a possibility when an overlap recycle that there can be two instances of your application running for a brief period of time. So that's why we provide the non-overlap recycle, which is more of a serial fashioned, happens serially. So it will terminate the old process first and then start the new one. Now, while you may lose some requests that are currently being processed in the old worker process, you'll reduce some of your you'll reduce the chance of multi-instancing if that was a problem in your app. But in both cases, new requests that arrive are still queued in the kernel, so there's no interruption in service from new requests coming in. It's just in the non-overlap recycle, you have the chance of losing some existing requests that are being processed. So this is a slide that goes into a little bit how an overlap recycle works. So the old worker process will signal to WAS that it's ready for a recycle. And WAS will, at that point, do a create process and start a new worker process. And at that time, there's still a chance that requests are coming into the old worker process. Now, at some point, the new worker process will signal that it's ready to begin processing requests, and WAS will send a shutdown message to the old worker process. So when this happens, then all new requests are sent to the new process, and the old one finishes and drains properly. So I'm going to switch to the demo machine and do a quick demo of how recycling works. So since I'm going to configure some recycling properties that will make this easier to show in a demo, so I'm going to recycle based on number of requests, and I'm going to configure my number of requests to be a small number, so let's say 3 or 4, so I can just refresh my browser and see the recycle event happen. So again, recycling is a property of the application pool. So I'll select properties of my app pool. And recycling is a tab, one of the property pages. I'll select recycle worker process after. By default, it's 35,000, but we're going to change that to 4. So if I switch back to my browser and start refreshing the page, so I have a new process ID of 292. If I keep refreshing this, 3, you will see the recycle happen. And actually, because I have these debuggers running, you can actually see the overlapped behavior. As I'll refresh a page, and then for a brief instance, you'll see 2 instances of the worker process running, and then one will terminate before the other one's done. And in addition to this happening, there'll be a message in the event log that your application has been recycled. Okay. Now, we've also extended the ISAPI programming interface to interact with this recycling feature. So if you're building any ISAPIs, like I said, ISAPI is the fundamental programming platform that applications like ASP are built on, or a lot of custom applications may use ISAPIs rather than using ASP. So there's a server support function in the ISAPI framework that allows an ISAPI application to signal back to WAS that it needs to be recycled. And so this can be useful if you can build some logic into your ISAPI that is smart enough to detect that it needs to be basically shut down. So, and I'll give you an example. I mentioned ASP hang detection. ASP actually takes advantage of the report unhealthy function. So ASP is an ISAPI that implements its own thread pool. Now what happens is, if you can imagine an ASP page, and maybe that's calling a COM component, and that component is calling another COM component down the chain, there's a chance that these threads can become deadlocked because it can't really detect what's going on in some other component that it's calling. So ASP has built in some logic that it can kind of tell when its internal threads become deadlocked, and it can't really restart them. And basically the only alternative is to shut down and restart the process. So that's a new feature of ASP is ASP hang detection, and that's based on the usage of this server support function report unhealthy. So I'll do a quick demo of this. So inside this ISAPI extension, I've implemented some code where, just for demo purposes, I'll pass it a parameter called unhealthy, and at that point it will signal to WAS that it needs to be recycled. Now I do have to apply some configuration properties to the application pool to allow it to do this. So I'm going to go back and look at my app pool properties, and I want WAS to be able to check this ISAPI more frequently than 240 seconds to know if it went down. So I'm going to have it check every 7 seconds. I think I'm actually going to go and remove my old recycle properties. So we'll simulate something going wrong in this ISAPI by passing it the unhealthy. That's not it. So essentially what has happened is that now this application is signaled to WAS that unhealthy was detected. I can look in the event viewer, and you should see an event message that the ISAPI extension reporting itself unhealthy, and that was the message that was coded into the extension that Eric has left the building. And so, but in addition to posting this event, you can actually see the next time I refresh this page, I'm going to have a new process ID, because WAS, and you can actually see it happening where it kills the process and restarts another one, because it assumes something has gone wrong in this, possibly in its thread pool or something like that. All right, so we'll switch back to this. Okay, in addition to recycling, we have these health detection features in IIS 6. So what health detection is basically a way that IIS 6 can detect if your app is running okay or not. So one of the components of health detection is the rapid fail protection state. So IIS can monitor the worker process and detect if it's crashing or not. And if you configure this, and let's say they call it, here's the number of crashes in a certain time period. If you configure IIS to detect when the web app is going down, it will actually put it in this rapid fail protection state, where it essentially disables the app pool, publishes an event to the event log. So when it's in this RFP, or this rapid fail protection state, no requests actually make it up from kernel mode into user mode. So you prevent burning any unnecessary cycles on the CPU. So if you have an app and it starts going down all the time, IIS can just automatically take it out of the picture. And you can configure this for, by default, it's 5 crashes in 10 minutes, and you can enable or disable this feature. So what happens typically, like in this second points here, normally when it crashes, IIS just restarts restarts the process. But if it's crashed too many times, then it will just disable it. do a quick demo. So again, this is an app pool property. Reset that back. So what I'm going to do is I'm going to enable rapid fail protection, but I'm only going to set it for 2 crashes in 5 minutes. So if I go back, refresh my page, oh, that's the unhealthy one. Okay, now how I can simulate a crash is I can just physically kill this W3WP instance. And again, this is because it's running in the system debugger. So if I do that a couple times and kill the process, I'll start seeing these messages that the application has been taken offline. And if I look back into the event log, there'll be a message in here that the application pool is automatically paused and due to a flurry of failures in the processes serving that application pool. So this is how IIS can automatically take the application offline by putting it in the rapid fail protection state. So now to re-enable it, I can just reset the app pool itself. And I'm going to go back and remove that property that I just set. Okay, there's another feature of health detection, another component called process pinging. Now this doesn't have anything to do with the TCP/IP ping that you do to detect if an IP address is valid. It's basically the communication channel that's set up between WAS and the worker process, and it's a Win32 named pipe. So what WAS will do is periodically send a message to the worker process to detect if it's still up and running. Now, the cases when it will not send back a response is typically when all of its threads are deadlocked. Now, and the process has a configured time limit to respond. So if the worker process does not respond to this named pipe message, the default behavior is to kill the process and publish an event and then start a new process. Or you can optionally configure IIS to take what's called a debug action. So what it will do is run some type of script application so you can actually analyze this worker process. And it will save it off in its current state. And that's sometimes referred to as orphaning. So like I said earlier, the configurable debug action, WAS detects that this process is locked because it fails to respond to a ping. You can configure some script to run if you want to send some notification or via email or something like that, hey, this process crashed. It can be used in debugging scenarios where the process is still running and you attach a debugger to it, or you run some type of application that can dump the internal state of the process. So a developer or a support person can look at the internal state of the threads and try to figure out what went wrong. It's important to know that this process is left running. So even though that WAS drops the process handle and starts a new one, that this process will still exist in its locked state, so somebody can actually debug it. So yeah, I think we'll have one more demo, and I want to actually show you how this debug action works. So typically for this demo, I'd been configuring the debug action to just use a net send. So I would send a message to myself. But I've noticed that, I don't know, this machine doesn't have a network attached, so my net send is not resolving the name. So I've wrote just a VB script application that displays a message box, and that will be my configurable debug application. So again, I'll go into my app pool properties. Under debugging, I can enable debugging and specify the file and the parameters that I want launched on this process that failed to respond. So I'm going to use the wscript.exe as my process. And, let me again reinforce that this is just a demo because, on any running web server, you're not going to be wanting to send messages. And actually, I had to enable the IIS admin service to interact with the desktop to be able to do this, which is not the default behavior. So the name of my script file is d:\alert.vbs. Just to make sure. Okay. So, and then what I need to do is decrease my ping frequency so I'll actually be able to detect this for purposes of this demo. So I'll set it to 5 seconds. So I'm going to refresh my page. Now I'm going to actually break into this process using the Control-C command of the debugger. And what that will do is actually lock it so it's not going to be able to respond to anything. And IIS detects it. It didn't respond to the ping, which was a name pipe message, and therefore launches this instance of, well, not really the debugger, but my script application, that this process went down. And if I run the script, refresh my application again, I can see that a new worker process got started, and this one that I broke into with the debugger is still out there running. So you can imagine at this point, something seriously has gone wrong with IIS, with the app, and you can, not with IIS, but with the app, and you want to get some support people in to maybe run a debugger on this process. All right. Right. Okay. So we've talked about the reliability features. We've talked about app pools. We've talked about the main components of IIS 6. I want to go into briefly some considerations that if you're building applications that you really need to think about, and they're based on this new process model. So one of the most important things to understand is that there can be now multiple instances of the worker process running your app. So I mentioned here no single locks, and what that means is if you're doing something in your application, such as writing to a file, like you're implementing your own logging in an ASP page and it's dumping some information to a text file, if that whatever it's doing is not transactional or it can't be accessed by multiple processes at the same time, you could potentially run into problems. Now, this probably would not be the case if the ASP pages are writing to a database because that's designed for concurrency. But if they're just writing to some physical file, you'd have to make sure your code was aware that there could be other applications holding on to this file, and you'd have to implement logic there. And the cases where multi-instancing will happen is if you do overlap recycles, if you configure a web garden. And you also want to consider persisting your state externally. So these worker process, they have a finite lifetime that's configurable. And the purpose of this is to configure system resources. So on my demo machine, you could see the worker processes starting. After some period of time, those will go away. And then new ones will be started as an as-needed basis. So if you're persisting state internally, like in just a session object, you need to consider that could be lost, and always, if you're going to use these multiple worker processes, consider persisting state externally, like in the ASP.NET state engine. And you may want to take advantage of the application pools just to isolate your applications you want to debug into their own application pool. And you could actually do this on a machine that's serving other websites, because through process isolation, you don't have to worry about it bringing down the web server. And I also wanted to mention ASP.NET. I don't know if you've been familiar with ASP.NET or been to the training or the sessions, that ASP.NET implements its own process model that's very similar to the IIS 6 process model. So if you install ASP.NET, on Windows NT or Windows 2000, it's going to run using the ASP.NET process model. And what this means is it has its ISAPI application, but then it will launch these worker processes, which are instances of ASP.NET or ASP.NET_WP.exe. It's a very similar architecture to IIS 6. But what you need to consider is if you deploy this .NET application on IIS 6, the ASP.NET will use the IIS 6 process model. So consider that where you made settings for recycling and health detection and any of the ASP.NET properties in the machine.config file, that on IIS 6 it's going to use the IIS metabase versus this file. So you want to consider that if you dropped your .NET application that you'd configured on Windows 2000, that you may not pick up the same machine.config settings as you had on Windows 2000 if you put that on IIS 6. And you definitely want to use this ASP.NET session state service is really good, and recommend using it because you don't have to worry about state management when you're doing recycling and when the processes are shutting down and starting. And then again, if you can't tailor, if there's things in your app that you can't change, so you can't change it to use because the overlap recycle, just disable those features in IIS 6. I mean, you can actually configure the worker processes to stay up and running all the time through the configuration settings. So I just want to wrap up and go over what we talked about. We went over the IIS 6 architecture. So the key takeaway there is to remember that the three main components are the kernel mode device driver, HTTP.sys, WAS, the configuration manager, and the worker processes. It's because of this architecture that IIS 6 is more reliable, because the applications are isolated from system components and other applications that are running. If you use the features such as recycling and health monitoring, especially in cases when you're hosting, when you can't change code and you're hosting problematic applications, and it's a really good alternative rather than scheduling IIS reset. And ASP.NET and ASP uses these new features like the report on healthy to further improve reliability, in their own implementation. So where can you get resources on IIS 6? So right now, I know this is a terribly long URL, but I couldn't get anything shorter than that. On TechNet is the IIS 6 overview, which is pretty good. Now, we actually have an IIS 6 architecture manual or guidebook that is not published yet, but it's close, and we're working on it, and that'll go out soon. The IIS 6 docs themselves are not bad. So if you're deploying Beta 3 or running Beta 3, it's got a complete metabase reference and fairly good information on configuring the process model. There's not a lot of specific guidance, but all the material is there. And I would encourage you to attend 302 and 306 on security. And I think 306 is later this afternoon. So thank you for your attention, and I'd like to open it up for any questions at this point.
Are .NET applications running more reliable on IIS 6? Are you going to get a performance gain as well, upgrading Win2K box running at runtime?
Right. Okay, so the question is, are .NET applications, do you get a performance gain running them on IIS 6? And the answer is, yeah, you get performance gains for, we haven't published any formal benchmarks, but yes, I mean, basically ASP and ASP.NET apps will run faster on IIS 6. And a lot of this is due to, the combination of the kernel mode stuff and the ability to isolate them in their own separate processes.
I noticed you had a feature where you could say, okay, this particular app tool has its own processor.
Mm-hmm.
But it'd be a lot better, I guess, if you had, say, 10 customers on a server, where you could say load balance all 10 customers across all processors, or say, each one has a certain percentage of the processor.
Right.
Rather than just bang and get one proc, if it's a 4-proc box, you're kind of limited.
Right. So the question is, make it more granular into.
Like policies where you can say,
right.
type of apps give it this percentage processor, load balance
Right. Yeah. Giving percentage processor time. Yeah, that feature, the question is, do we have any plans to put percentage of processor time to given apps? And we haven't got that granular yet. So, you know, if you could imagine maybe a box where you had 8 customers, you could balance them to specific CPUs, but we can't do anything with CPU times yet. Yeah. Yeah, essentially. You had a question back there?
Well, I think it's implied by the diagram, but I guess HTTP.sys uses TDI and bypasses the WinSock kernel mode driver.
Correct. So the question is on the internal implementation of HTTP.sys. Yes, and so WinSock is not used in IIS for actual TCP/IP listing services. It's all re-architected, and that goes through TDI in HTTP.sys, and that's where the majority of the IPv6 code is all implemented. It's down at that layer. But WinSock is still there, and it's still used by, you know, FTP and I guess any other web servers that don't use HTTP.sys will most likely use WinSock.
Using IIS 5 now for hosting content, there's a sort of trade-off between, on the one hand, you want as many sites as possible
Right.
in DLL hosts. On the other hand, if you do that, the more you have, the more difficult it is to trace properly with
Right.
sites. Is there anything there that addresses that? Because I would think you still want to keep the number of application pools down.
Right.
Just to keep the box runnable or to keep a large number of sites running on those.
Right. So I guess the question is, maybe it's hard to maintain a large number of application pools. Yeah. So here's the thing to consider with when doing this. So I'm a hoster, and I've got 1,000 sites on a box. I configure them there in each instance of an application pool. What that means is that, so potentially, you know, depending if all 1,000 customers, their clients hit the web server at one time, you spawn 1,000 instances of the worker process running. Now, is that likely? Maybe not. Maybe as you're the site admin, you had a good idea that that would not likely happen. So, I guess so. The question is managing that. You know, IIS 6 is more scalable. I mean, you could not in IIS 5 achieve that many isolated processes in DLL host. I mean, there would just be a finite limit where it just wouldn't work. I mean, now we have the flexibility to scale that number really high, but you know, yeah, you need to consider how you're going to manage that, and maybe you can talk to me later after that, because there's a lot of different factors. So, and actually, our performance guy is here too, and that's
There is the queue, request queue is for the application for all processing application, or there is a one queue for each process.
right. Yeah. So, how does the request queue in HTTP.sys work, basically? So, this is its own internal queuing mechanism. So basically, when any process, I mean, you know, we'll say in terms of IIS, when a worker process or WAS sets up the communication channel between a worker process and HTTP.sys, it kind of binds it to this queue, and it communicates through I/O completion ports. So there's an I/O completion port set up between HTTP.sys and the worker process, and it basically the worker process knows specifically what queue they're monitoring and pull requests off of and then send them back.
One queue
No, there'll be multiple queues. So any application pool that's configured, there's basically one queue set up. So if you have a web garden of 4 processes, I'm almost 99% sure they're all pulling off that one same queue.
So this schedule is done by the schedule of the request.
The scaling of the requests?
Yeah. Have 4 processes.
Yeah.
One application.
Right.
And 4 queues.
Well, there would be one queue. So for one application pool has 4 worker processes, there would be one queue, and those they would share the requests coming off. Right.
So each subsequent, actually the conditions around logging, each subsequent connection gets sent to the worker process, but it's kept alive.
Any more? One more.
How's the operator?
Oh, good question. Upgrade process from 5 to 6, because there's some things you got to think about here. So if you upgrade, basically you can do an in-place machine upgrade. You just reinstall the operating system, or you can build it from scratch. If you upgrade, what will happen is that IIS 6 will go into this compatibility mode architecture. So it's almost is identical to IIS 5. So you will have to actually go in there and create your individual application pool. So none of that is set up. It's essentially going to run in the same mode as IIS 5. So if you do an in-place upgrade and then you want to go start using some of these new IIS 6 features, you'll have to go in there and configure that, basically. Yeah, I think that's it.
Is it possible to load IIS 6 on a Windows 2000 box?
No. The question, can you run IIS 6 on Windows 2000? And it's basically, we're part of the OS. So there's no, and it's because, components like the kernel mode component is part of the OS. It's not really something that you can move to another box. Yeah, there's all kinds of stuff that changed. psked and stuff. So. Okay, I guess we're done. If you have any more questions, you can just come up to the podium, and thanks.